welcome to Easy BTech, your grade 4 BTech and beyond. In this video, we'll learn about how we can evaluate velocity of wave propagation. Evaluation of velocity of wave propagation. Okay. Suppose, for example, if you take already we derived the forward incident voltage and reflected voltage waveform derivation in wave equation. If anyone don't know about that one, we can go through that video where we'll identify, we know how we can evaluate forward direction and reverse direction. Okay, from that forward direction, the incident voltage waveform is equals to, we represent with the function of root LC x minus t. Okay, this is the incident waveform. In the incident waveform, I am taking only this function. Suppose I am taking s equals to root LC x minus t. Differentiate this s. So suppose this is equation 1. First, we have to differentiate equation 1 with respect to t. Okay, what you get if you differentiate with respect to t, you get 0 equals to root LC dx by dt minus 1. Okay, from this equation, the root LC dx by dt equals to 1. From this, dx by dt equals to 1 by root LC. Finally, you get dx by dt equals to 1 by root LC. What is this dx by dt? Here x is the distance, and t is time. Therefore, dx by dt, it indicates that velocity. Okay, the dx by dt indicates that velocity. The velocity of traveling wave is depending upon inductance of that line and capacitance of the line. Now, we will calculate the velocity of wave in two cases. In the first case is overhead transmission line, and second case is underground cables. In overhead transmission line, we know the inductance equals to 2 into 10 power minus 7 ln if GMD equals to D and GMR equals to R dash. For simplification purpose, I am neglecting the internal flux linkage, therefore GMR also becomes R. Okay. Now capacitance value for overhead transmission system is 10 power minus 9 divided by 18 ln GMD is capital R and GMR is small r. Okay. Now substitute in velocity of waveform. I am representing dx by dt equals to v. The v equals to 1 by root LC. Substitute L value, C value here. It is 1 by root 2 into 10 power minus 7 ln d by r divided by 10 power minus 9 divided by 18 ln, sorry, it is not divided by, I am representing. It is 1 by root LC. It equals to root of L value for overhead transmission line. It is 10 power minus 7 ln capital D by R into C. C is 10 power minus 9 divided by 18 ln D by R. D by R get cancelled. Therefore, finally you get 1 by root of 2 into 10 power minus 7 into 10 power minus 9 divided by 18. The resultant of this value is 3 into 10 power 8 meters per second. Okay, the velocity of wave in overhead transmission system is 3 into 10 power 8 meters per second. For underground cables, next case is for underground cables. In underground cables, velocity in underground cable, the formula is root LC. It is nothing but dx by dt. I am representing with velocity v 1 by root x. Both the cases formula is same, but the formula for inductance of an underground cable is 2 into 10 power minus 7 ln capital R by small r. R is the radius of outer radius of the conductor, small r is inner radius of the conductor, and C capacitance of underground cable is 10 power minus 9 epsilon r divided by 18 ln capital R by small r. Therefore, the L value and C value substitute here, substitute in this expression. Both L value and C values are substitute in this expression. We get velocity v equals to 1 by root LC. This is equals to 1 by root of 2 into 10 power minus 7 ln capital R by small r. Here also I am representing, I am not taking the internal flux linkage. Then R dash becomes R into C value 10 power minus 9 epsilon R divided by 18 ln capital R by small r. Therefore, here also ln 1 R by R, ln R by R get cancelled. Finally, what you get, calculating this, we get 3 into 10 power 8 divided by root epsilon R meters per second. This is the velocity of wave in underground cables. Next, we will compare the velocity of waveform, velocity in overhead transmission line and underground cables. In overhead transmission line, it is equals to 3 into 10 power 8 meters per second. In underground cables, it is 3 into 10 power 8 divided by root epsilon r meters per second. Then it is clear that in underground cables, the velocity of propagation is depending upon the relative permittivity of the insulating material. In overhead transmission system, it is directly speed of light. In underground cables, it is depending upon type of resisting material. Okay, now we will see a simple problem on this. Simple problem. The problem is a underground cable, a underground cable has a conductor of radius 0.75 centimeters and a sheath of inner radius 2.5 centimeters. Here you have to find the first one is inductance per meter, second one is capacitance per meter, and third one is surge impedance, and fourth one is velocity of the wave. Okay, if velocity of wave, if relative permittivity of the material or insulation is equals to 4. Okay, now for solution, first we have to take the smaller value. They provide 0.75 centimeters and outer sheath radius is 2.5 centimeters and epsilon r value is 4. They given this information. We know the formula for inductance. Inductance L equals to 2 into 10 power minus 7 ln capital R by small r. Therefore, substitute those values here. 2 into 10 power minus 7, 2.5 divided by 0.75. You get inductance equals to 2.41 into 10 power minus 7 Henry per meter. The capacitance value is, the capacitance C equals to 10 power minus 9 epsilon r divided by 18 ln capital R by small r. Substitute those values here. 10 power minus 9 into 4 divided by 18 ln 2.5 divided by 0.75. You get capacitance is 0.1846 into 10 power minus 9 farad per meter. And we know the formula for ZS. For third case, we need to calculate surge impedance. ZS is root L by C. Already values is there. Just substitute those values. Here 2.41 into 10 power minus 7 divided by 0.1846 into 10 power minus 9. You get the impedance is 36.13 ohm. Last case, the velocity V. We know the formula, the velocity V equals to 1 by root LC. Therefore, substitute those L value and C value here. 2.41 into 10 power minus 7 into 0.1846 into 10 power minus 9. Therefore, this value is equals to 1.5 into 10 power 8 meters per second. This is the way we will calculate. Also, we can calculate and just now derived this velocity in underground cables also. Use that formula. What is velocity for underground cables? It is 3 into 10 power 8 divided by root epsilon r. It is 3 into 10 power 8 divided by root of epsilon r is 4. Root 4 it becomes 2. Therefore, 3 into 10 power 8 divided by 2, you get 1.5 into 10 power 8 meters per second. Both the cases observed, the answer is same. Okay, you can use any one formula. This is the way we will evaluate the velocity of a wave propagation in overhead transmission system and underground cables. Thank you for watching.